Ray just photographed something that shouldn't exist. And that's not clickbait. That's a factual problem for modern astronomy. Multiple telescopes, different nights, completely different setups, all showing the same impossible thing. And this time, we're not talking about a blurry dot that could be anything if you squint hard enough. We're talking about a crystal-clear image of an object from outside our solar system doing something that has never been documented before. NASA addressed it publicly and brushed it off with a single word: geometry. Clean, elegant, reassuring. Except the contradictions never went away, and now there's visual proof staring us in the face. What Ray captured at closest approach isn't vague, isn't subjective, and isn't easy to explain away. And the silence from professional astronomy might be the most interesting part of this entire story. So stay with me, because what you're about to see isn't just strange. It forces us to confront how little we actually understand about objects that come from beyond our cosmic backyard. This was the sweet spot astronomers wait for without ever being sure it will arrive. A moonless night, exceptionally clear atmospheric conditions, and an interstellar object passing through at exactly the right moment. Ray pointed everything he had at 3I Atlas during its closest approach to Earth, knowing this was likely the best chance humanity would ever get to see this object clearly before it faded into permanent obscurity. He wasn't guessing or improvising. He followed the same rigorous imaging process used for comets everywhere: noise removal, comet alignment, careful stacking, the kind of work that separates real signal from wishful thinking. And when the processed images came together, the result wasn't just good, it was unprecedented. A compact central core exactly where it should be, a primary dust tail extending outward like textbook comet behavior, and then something that immediately broke the rules: a second tail, fainter but sharply defined, pointing in a completely different direction. Not smeared, not chaotic, not inconsistent, but clean, stable, and repeatable. This wasn't a fluke image or a processing artifact, because the same geometry appeared again and again, across different nights, different observers, different equipment. At that moment, the question stopped being, "Is this real?" and became something far more uncomfortable. What could possibly be causing this? NASA's explanation sounds simple on the surface. After perihelion, the viewing angle changes, Earth shifts position, older dust particles align in a way that creates the illusion of a sunward-pointing tail. According to brightness contour maps, the dust distribution follows a smooth, predicted plane rather than localized jets, suggesting this is all a trick of perspective rather than physical thrust or propulsion. And on paper, that explanation works for appearance alone. But Ray's images don't just show a visual illusion, they show structure. The jets aren't fuzzy or chaotic, they're sharp, directional, and consistent, appearing on one side in one image and rotating to another position in the next, as if something on or within the object is actively shaping the outflow. The stars trail across the frame due to long exposures, but the object itself remains tight, stable, and locked in place, which tells us this isn't motion blur or noise. It's real signal. And here's the key problem. Geometry can explain how dust looks, but it doesn't explain why that dust exists in the first place, especially when earlier observations said it shouldn't. Before perihelion, the Very Large Telescope did exactly what it's supposed to do. It searched for hydroxyl and cyanogen, the defining molecular signatures of cometary activity. It found nothing. Zero. By strict definition, that means 3I Atlas should not behave like a comet at all, more like a rocky, inert asteroid with maybe some surface dust. Visually, it looked active. It had a coma. It looked alive. But spectroscopy doesn't lie. So it was classified as a silent comet, inactive, not outgassing, fundamentally dead. And here's where physics becomes a brick wall. You cannot activate what isn't there. The sun doesn't create new chemistry, it only heats existing material. If there were no cometary gases before perihelion, there should be no activity afterward. And yet that's exactly when everything changed. After its closest approach to the sun, 3I Atlas brightened significantly and began producing visible jets, stable, continuous outflows of material. Ray's images show sustained dust production, not a brief chaotic burst, not fragmentation, not irregular spikes, but controlled ongoing activity. It's like scanning an empty fuel tank. watching the car start and being told that's normal. It isn't. As if that weren't enough, there's the X-ray problem. Japan's space agency detected X-ray emissions from this object. Carbon, nitrogen, oxygen ions, exactly the kind of emissions produced when solar wind interacts with a gaseous coma. This mechanism is well understood and observed in comets for decades, but it requires gas, real gas, interacting with charged particles. So now we have a paradox. VLT says there are no cometary gases. JAXA says there must be gas because the X-rays are there. Both instruments are world-class. Neither makes mistakes like this. NASA's response is different chemistry, exotic volatiles formed in another star system, gases we weren't looking for. And in theory, that could be true. But theory isn't evidence. Show the spectroscopy, show the molecules. Because right now, geometry explains appearance, but not activation, not X-rays, not timing, and not the remarkable stability of the observed structure. What Ray documented isn't just unusual, it sits at the intersection of multiple contradictions that no single explanation currently resolves. And the most unsettling part is that this object is leaving. Every night it gets fainter. Every day the opportunity to resolve these questions slips further away, and the best visual record of its closest approach now comes from an independent observer working outside institutional timelines. One of the most uncomfortable questions raised by Ray's images came up directly during a public NASA Q&A. Why are amateur astronomers sometimes producing clearer, more revealing images than major space agencies? The official answer was polite and technically correct. Different tools, different missions, different priorities. Many of the spacecraft that observed 3I Atlas near perihelion weren't designed for imaging at all. They were heliophysics missions studying the sun, magnetic fields, charged particles, not morphology. Ground-based telescopes couldn't observe the object at that time due to solar glare, so imaging opportunities were limited. Ray's images came later, when the object moved far enough from the sun to be visible under dark skies, using long exposures optimized for visible light. But here's the deeper issue. NASA knew this object was coming. The trajectory was known. The opportunity window was narrow but predictable. And yet there was no massive, coordinated imaging campaign dedicated to capturing its structure in detail during closest Earth approach. Instead, we got fragmented observations, each facility fitting the object into their existing schedule. Ray, unconstrained by proposal committees or institutional timelines, simply observed every clear night, adjusting his methods in real time. Not because he had better equipment, but because he had freedom. And that freedom produced some of the most valuable data we have. The more Ray documented 3I Atlas, the more troubling its behavior became. The dual-tail structure didn't smear, didn't rotate unpredictably, didn't fragment or dissipate as viewing geometry changed. Night after night, the same coherent morphology appeared, locked in place. In normal comets, activity is messy. Jets erupt from localized regions, rotation causes variability, brightness fluctuates as different surface patches face the sun. Hubble images have shown this countless times: irregular outflows, uneven structures, chaotic dust patterns. But 3I Atlas was different. Too smooth, too uniform. The emission appeared distributed, not coming from isolated active regions, but seemingly from the surface as a whole. That alone is unprecedented. For that to happen, the surface would need to be uniformly volatile, sublimating evenly despite rotation, something never documented in centuries of comet observations. Ray also documented a cone-like or funnel-shaped structure trailing the nucleus, a geometry that persisted even as the object dimmed with distance. If this were a temporary effect or a processing artifact, it would fade or morph. It didn't. The structure remained stable, suggesting whatever process drives it is intrinsic to the object itself, not a fleeting interaction or observational illusion. When you line up the events chronologically, the problem becomes impossible to ignore. Before perihelion, the VLT searches for hydroxyl and cyanogen and finds nothing, implying an inert body. At perihelion, maximum solar heating occurs, the moment when any hidden volatiles should react most dramatically. Then, after perihelion, when the object should be cooling, it activates. Brightness increases. Jets appear. dust production ramps up in a controlled, sustained way. Weeks later, during closest Earth approach, RAY's images show ongoing activity, stable structure, continuous outflow. This is the opposite of what standard comet models predict. If a thick crust cracked open, you'd expect irregular bursts, spikes in brightness, maybe even fragmentation. Instead, what we see is smooth, deliberate emission, almost as if the object switched into an active state and stayed there. That's why the silent comet label collapses under scrutiny. Silent comets don't suddenly wake up after perihelion. The sun doesn't flip a switch on chemistry that wasn't present before. Something about this object doesn't align with our assumptions about how small bodies behave. This is where the story stops being about a single object and starts challenging our entire framework. Every comet and asteroid model we have is based on objects formed in our solar system, the same protoplanetary disk, the same elemental ratios, the same 4.6 billion year history. We've built a classification system that works beautifully for local objects. But 3I Atlas didn't form here. It came from another star system, potentially with completely different chemistry, metallicity, and formation conditions. We might be forcing it into categories that simply don't apply. Just like trying to classify a lion using only marsupial biology, the framework breaks when the sample comes from a fundamentally different environment. The idea that interstellar objects are just normal comets with exotic ice might be wrong at a foundational level. Different stellar environments could produce volatiles we don't routinely look for, gases that evade standard spectroscopic searches but still interact with solar wind to produce X-rays. That would reconcile some contradictions, but it also means our detection strategies are incomplete. And if that's true, then 3I Atlas isn't an outlier, it's a warning. A signal that our models are local, not universal, and that when truly alien material passes through our neighborhood, confusion isn't a bug, it's the expected outcome. The X-ray detection changes everything, because X-rays don't lie. JAXA's observation of carbon, nitrogen, and oxygen emission lines places this object squarely in a category that requires real, physical gas interacting with the solar wind. This is not speculation, it's textbook physics observed in dozens of comets since the 1990s. Solar wind ions slam into neutral atoms in a coma, steal electrons, and when those electrons drop energy levels, X-rays are emitted. Simple, elegant, well understood. But that mechanism collapses if there's no gas, and yet VLT said there wasn't any. So we're left with two mutually exclusive realities that somehow both exist at the same time. Either the spectroscopy missed something fundamental, or the X-ray detection is being misinterpreted, or the object is producing gases we're not equipped or accustomed to detecting. NASA leans on that last option, different chemistry, exotic volatiles, interstellar origin. And again, that's not unreasonable, but it's incomplete. Because saying different chemistry, without identifying the chemistry, isn't an explanation, it's an admission that we don't know what we're looking at yet. And while institutions phrase that uncertainty carefully, RAY's images quietly amplify it by showing ongoing activity that absolutely requires a physical source. The geometry explanation only works if you already know the properties of the dust, its size distribution, its velocity, how radiation pressure affects it, and how it responds to solar heating. But every one of those parameters depends on composition, which we don't actually know. The predicted dust plane NASA references is built on assumptions, not direct measurements. It's reverse engineering an explanation from incomplete inputs, and that's where RAY's data becomes so disruptive. His images show jets that rotate between frames in a way that suggests structure, not random dispersal. You can literally see the emission shifting position, wrapping around the nucleus as if something is spinning beneath the surface. That behavior doesn't emerge from a passive dust sheet viewed at a clever angle. It implies a source. It implies organization. And while that doesn't mean propulsion or artificiality, it does mean something more complex than a simple geometry trick. The explanation addresses how it looks, not why it behaves that way, and those are very different questions. What keeps standing out is how controlled this object appears to be. Space is violent. Solar radiation, thermal stress, rotational forces, all of these tend to produce chaotic outcomes when small bodies activate. We've seen it countless times. Comets flare unpredictably, fragment, shed material in bursts, sometimes even tear themselves apart. But 3i Atlas doesn't do that. Its activity is steady, its structure is coherent, its dual-tail geometry remains locked in over time. Even as it fades with distance, the morphology doesn't collapse or devolve into noise. That suggests whatever is driving this activity is not a fragile surface phenomenon, but something intrinsic and stable. The idea of simple crust cracking doesn't hold up, because cracks produce irregularity. This doesn't look irregular, it looks regulated. Not intentional, but consistent, like a mechanism operating within known limits rather than a failure cascading out of control. And that's exactly why it's so hard to fit into existing comet models. While all of this is happening, the object is leaving. Every day it gets dimmer, more distant, harder to study. Ray continues imaging it night after night, building a farewell sequence that shows not just fading brightness, but persistent structure. The dual tails, the cone-like morphology, still there, stubbornly refusing to disappear as signal strength drops. If this were a transient artifact, it would dissolve into noise. It doesn't. And that makes the institutional response feel painfully slow by comparison. Papers will be published, analyses will be debated. But by the time consensus forms, the object will be gone. We'll be left arguing over archived data instead of interrogating the source directly. Ray's work is effectively freezing this moment in time, creating a visual record of an interstellar visitor behaving in a way our models don't predict, at the exact moment when it was closest and clearest. And that record will outlive the opportunity itself. There's a moment in every scientific anomaly when it either collapses under scrutiny or hardens into a real problem, and that moment is reproducibility. One image can be dismissed, two can be debated. But when multiple observers, on different nights, using different telescopes and different processing pipelines all recover the same geometry, the same secondary tail, the same stable structure, you've crossed a line. Ray wasn't alone. Independent observers reported the same features, the same orientations, the same behavior. That eliminates the usual escape routes: camera glitch, processing artifact, atmospheric distortion. Those effects don't synchronize across instruments and nights. What emerged instead was something far more uncomfortable: a consistent physical structure associated with the object itself. At that point, the discussion stops being about whether the data is valid and starts being about whether our interpretive framework is sufficient. And that's where the tension really begins, because validating the data removes the safety net. During the public AMA, NASA made a statement that sounds definitive but actually isn't. All available evidence supports a natural origin. That sentence does a lot of work, and most people don't notice what it quietly avoids. Natural does not mean explained. Natural simply means probably not artificial. It says nothing about whether current models can account for what we're seeing. The unusual features are attributed to interstellar origin and different formation chemistry. But again, attribution is not identification. No breakdown of molecules, no confirmed volatile inventory, no post-perihelion spectroscopy publicly resolving the contradiction. The phrasing creates the impression of closure while leaving the core questions open. Ray's images don't contradict the idea of a natural object, but they do expose how thin the explanatory layer currently is. We're calling it natural because we don't have an alternative category, not because we've actually solved the physics behind its behavior. This all feels uncomfortably familiar. In 2017, another interstellar object passed through. Strange shape, unexplained acceleration, no visible outgassing. Natural explanations were proposed: hydrogen icebergs, exotic compositions, speculative but mathematically convenient ideas. The problem was never whether those explanations were possible, it was that they were untestable after the fact. The object was already gone. The debate continued in papers and conferences, but the evidence window had closed. With 3i Atlas, we're watching the same pattern repeat in real time: initial confusion, partial explanations, cautious institutional messaging, and a rapidly closing observation window. The difference this time is that Ray's documentation is far more detailed during the critical phase. He's not reconstructing the mystery after the fact. He's capturing it as it unfolds. And that creates a historical record that didn't exist before, one that future researchers won't be able to ignore. At some point, the issue stops being about this object alone and becomes about the system we're using to describe it. Comet, asteroid, active, inert. These categories work extremely well for objects born in our solar system, shaped by the same materials, the same radiation environment, the same evolutionary history. But interstellar objects don't share that background. They're immigrants from entirely different stellar neighborhoods, carrying formation histories we've never sampled directly. Forcing them into local categories may be the real mistake. 3I Atlas behaves like a comet when it shouldn't, activates when it shouldn't, produces emissions that contradict prior measurements, and maintains structure in ways that defy expectations. That doesn't automatically make it exotic in the sensational sense, but it does make it incompatible with a binary classification scheme designed for local debris. And if that's true, then the confusion surrounding this object isn't an anomaly. It's a preview of what's coming as detection methods improve and more interstellar visitors are discovered. So here's where we actually are, once you strip away the polite language, the institutional caution, and the comforting explanations. An object from outside our solar system passed through our neighborhood, and at the moment when we should have understood it best, it did things our models don't predict. Before perihelion, it showed no cometary gases. After perihelion, it activated. It produced jets. It brightened. It generated X-rays that require gas to exist. It maintained a stable, coherent structure night after night, documented independently by multiple observers, using different instruments, across different conditions. Every individual piece can be partially explained if you isolate it, but taken together, they form a picture that doesn't settle neatly into any existing category. And that's the uncomfortable truth. Not that this object is artificial, not that it's some cosmic threat, but that we don't actually understand it as well as we pretend we do. Natural origin sounds like an answer, but it isn't. It's a boundary, not an explanation. It tells us what the object probably isn't, while quietly admitting we don't yet know what it is. The contradictions between spectroscopy, X-ray detection, and visible morphology haven't been resolved. They've just been compartmentalized. Geometry explains appearance, but not activation. Exotic chemistry is invoked, but not identified. Classification is applied, even as the object actively resists it. What makes this moment historically important isn't just the object itself, it's how it was documented. While institutional astronomy moved on normal timelines, constrained by schedules, proposals, and publication cycles, an independent observer captured the most detailed visual record we have of this object at its closest approach. Not by making bold claims, not by forcing answers, but by doing something far more valuable, showing the data clearly, reproducibly, and without pretending it makes sense when it doesn't. That archive will outlive the debates. Years from now, when new interstellar objects are discovered and our models have evolved, researchers will come back to these images and recognize them for what they are: early evidence that our local frameworks don't always apply to foreign material. We've seen this story before. An interstellar visitor arrives. It behaves strangely. We rush to explain it using familiar tools. The object leaves before the questions are settled. The debate continues in hindsight, safely detached from observation. The difference this time is that the record is better, clearer, harder to dismiss. And that record suggests something fundamental. Interstellar objects may not be rare curiosities that occasionally look odd. They may be telling us that the universe builds small bodies in more ways than we've accounted for. That our comet and asteroid labels are local dialects, not universal languages. 3I Atlas is leaving. It's already fading, already becoming inaccessible to all but the largest instruments, and soon it will be gone entirely. What remains is the data, the contradictions, and the realization that for a brief window, something truly foreign passed through our solar system and challenged our assumptions without saying a word. Whether future observations resolve these questions or deepen them depends on whether we're willing to admit uncertainty when the evidence demands it. If you want to keep following discoveries like this, moments where the universe quietly breaks our expectations, make sure you're subscribed, because the next interstellar visitor won't announce itself politely, and when it arrives, the only people who will understand what they're seeing are the ones paying close attention,